Welcome. We're working on the review for Chapter 2 in Physics 1. And, oops, I need to open my... Okay, let's start over. Welcome. We're working on the Chapter 2 review guide. And I'm going to be specifically working on question 11. So, Chapter 2 review, number 11. And here's where we have two bicyclists. Now this is very much similar to our question 7 from last night's homework. That's homework 2.5, number 7, with one slight difference that'll actually make this a little bit easier. We have a bicyclist that is repairing his bike and is at rest, and his friend moves by him at a constant velocity. So right off the bat, I'm going to illustrate the friend here. So this is going to be velocity versus time graph. So the constant velocity of the friend is 4.5 meters per second. And the friend continues to move at this velocity on down the road. Now the bicyclist, as soon as his friend passes him, he gets on his bike. He starts from rest, but he gets on his bike and he accelerates to catch up with his friend. That didn't quite match up with the end right there, but that's okay. We'll just call that the end right there. He accelerates to catch up with his friend. Let me erase that last part. So, the question is, the first question in part A, I'll put that A right there, is how much time does it take for him to catch up with his friend? This is a time equals 0 right here. This is velocity equals 0 meters per second. And we would do well to actually write down all of our knowns for each of the two bicyclists. The first guy, I'm going to just call the bicyclist B, and I'll write his knowns in red. And the friend will be F. But let's write down the knowns for the bicyclist. The bicyclist's initial velocity is 0 meters per second. We are also told that, I forgot to write this, that the acceleration of the bicyclist is 2.8 meters per second squared. So we can write that down here. Acceleration is 2.8 meters per second squared. Do we know the final velocity? We don't. The way I drew this, it looks like the final velocity should be 4.5 meters per second, but if you think about it, if somebody moves past you at a certain speed and you accelerate up to that speed and stay at that speed, you will never catch up with them. You must actually be going faster to catch up to that person who had a head start, so we don't really know our final velocity yet. We do, however, know that the time of the bicyclist is going to equal the time of the friend because he gets on his bike right away when his friend passes him. And we know that the distance or the displacement of the bicyclist is going to equal the displacement of the friend. As for the friend himself, well, let's write this over here. F, the initial velocity is 4.5 meters per second. And the final velocity, VF, is going to be 4.5 meters per second, which means if the velocity does not change, the acceleration is going to be equal to 0 meters per second squared. And like we said before, time of the friend is equal to the time of the bicyclist, as is the displacement of the friend equal to the displacement of the bicyclist. Now we don't know time or displacement, but what we can do is we can find, we have equations that solve for displacement, and since the two displacements are equal to each other, we can set those two equations equal to each other. And I will solve the last part of this in the second part of the video because I'm running out of time. See you then.